This video I'm going to introduce some basics about raster data. So here we have the base map, which is essentially a base map is also raster data. And so you can see it different resolutions as far as the tapestry that it creates the base map we see here. So a lot of base maps, especially ones that we see here that are aerial photographs, are examples of raster data in and of themselves. But what I'm going to do is introduce two different types of other raster data, one based on a theme, and then another one based on, in this case, elevation, so based on continuous data. So first off, what I have here is this particular raster, and all this is very simple. This says if it's a forest area, it's green. If it's not forest area, it's gray. So it's very simple. We can kind of see how this overlays this particular raster, this particular grid, this rectangle. And so we can see how it overlaps with those forested areas that we can see in those dark green areas here in the aerial photograph. So let's go ahead and take a look. Okay, what's this telling us? So it's telling us some key information. So we look at the source, the columns and rows. And so go to move it over here, columns and rows. And so there's 1,191 columns. And so going this way, as we go from left to right, and 967 rows going horizontally. We look at the cell size, 30. What we're going to do is we're going to compare that to one that's 3, with the cell size 3. And so this is very important, is resolution. So the book mentions this early on when it talks about raster as far as cell size. So when the cell size gets smaller, the resolution gets better. So that relates to maybe if you're familiar with televisions. Right now, for example, my parents have a standard def television, and the number of pixels, it's 480p. Meanwhile, I got a cousin who's got a super nice TV they can't afford that's got 2,000 some pixels, and so it's much higher def, and so it has much higher number of pixels inside the same size television. So that kind of relates pixels. We're going to see pixels as a term that's used also in terms of raster data as well. So some other things, look at the size, 1.1 megabytes. So that's the size, and I'm more just using this for comparisons. We see its extent, this top, as far as its extent, is all spatial information regarding these coordinates here, the edges, the corners of this rectangle. So let's go ahead and look at and compare this to a digital elevation model that's at a much higher resolution. So this is showing elevation. In this case, it's not something based on a theme, whether or not it's forest or not. In this case, it's based on elevation. So it's showing continuous data. And so we see numbers as low as negative 114 and numbers as high as 785. And so those are elevation figures. So let's go ahead and look at some properties of this particular table. And so we see the columns and rows. Look how many more columns and rows there are. In the previous one, there was 1,191 columns, 967 rows. So we see a whole lot more number of columns and rows, and so the cell size subsequently has gone down to now 3. So also, as a result of that, look at the size. Now I'm going to zoom in so we can see a little bit more as far as how these pixels look. And so if we zoom in, let's kind of zoom into the coastline here. And now eventually we zoomed into this particular area here. And so we can use the identify tool here to, so this one here is 0, in that case is not forest area. So this was based on the idea that it's kind of looked at this whole entire area and determined that more of it is not forest, thus the classification here in terms of being 0 or not forested versus this particular pixel being 1, a value of 1 meaning it does have. Now let's go ahead and we'll switch out and put in the digital elevation model. And we see along this coastline here, this steep change in elevation. So it's very steep slopes. And so as it goes from white, the highest values goes down very considerably down to the coastline here. So now what I'm going to do is I'm going to zoom in and try to get an individual pixel if I can. And after about 15 minutes, once again showing one of the burdens of high resolution and just a lot of raster data sets in general is they are large files. and so they could really bog down computers, which makes it a little different with vector data, which tends to be much quicker and smoother. And so let's take a look at this. So I zoomed in, and so over here is towards the coastline, and then up here was up the slope. So this is the area I zoomed in. So I zoomed in as close as I could to get to individual pixels. And so I'm going to click on the identity tool and say, what's this value of this pixel? And so that value is 268 in this case. And so what would this pixel right here, you think it would be higher, should be a higher value, and it's 270. And so as we go down the slope, we can see it's 265, 262, and so on. So you can see how these individual cells, in this case, because it's showing elevation, contain an attribute, and that attribute is its pixel value, meters above sea level.